Hello and welcome everyone. In this video I want to talk about how I use ChatGPT to finish plugin features sometimes. I don't often use ChatGPT for that. My go-to AI is GitHub Copilot because I can use it directly in the IDE. But one thing that ChatGPT can do is explaining things in natural language, and that sometimes comes handy. I had a low-pass filter and I wanted it to have AutoGain because I had the problem that when you turn down the cutoff frequency in Hertz to a really low value, it got very quiet because it removed all of these frequencies. So I wanted to know what can I do about it. I started my conversation like this. I wrote a low pass filter and its processing function looks like this. Do you understand? So I just asked ChatGPT this very simple question and not directly the question that I was wondering about, because I wanted to make sure that ChatGPT knows that this is about a DSP code and about a filter specifically, and also what kind of filter, like how does the processing work, because the way the coefficients are generated depends on what the processing actually does. So ChatGPT confirmed that it understands what's going on and what the variables are and like what it means mathematically, and that the variables have to be declared and initialized somewhere else in the code for this to work. So I said correct, the variables are declared in this method actually. I gave it the method setX in which A0 and B1 are declared with some mysterious input float x in this way, and it said, "Thank you for providing the additional code. The setX method is responsible for setting the coefficients A0 and B1. It again explains what's going on mathematically, and then it says what this is useful for and that this relates to how ProcessSample works. Note that this is also the method that has to be tweaked in order to find the AutoGain value. But I didn't ask ChatGPT immediately for what I should do here because I wasn't sure at this point yet if ChatGPT would understand what X even consists of. I wanted to make sure that ChatGPT has an understanding for that, so I just gave it some more methods. I said, that's correct, setX is being called by this function in which you can set the frequency or decay in samples. So input D, make decay in samples, set X with exponential of -1 divided by D. This is code that I think I got it from Will Perkel's book of designing audio effect plugins in C++, or maybe I got it from dspguide.com. I have no idea anymore. The point is I have no idea why exactly this term works, but it does, and that's kind of weird because I want to understand the code that I'm writing. Still, it works, so I take it for now, but that just as a side note. So again, it said, thank you for providing the additional code. It explains what the code is doing, like mathematically, and the purpose of this code. And I say, correct, here are some more methods of that class. I use these to be able to set X from a frequency value in Hertz. So I gave it some more methods. And at this point, I did that because I wanted to let it know that this is not just about decays, but also about frequencies, even though that's technically the same thing. But, conceptually, it can be a little bit different. I wrote this low-pass filter initially for the purpose of parameter smoothing, which is why a lot of the functions have the word decay in the name, because it was not about setting frequencies in Hertz, but much more about designing how long it takes until a parameter value reaches its destination. So the decay of this transition. But I wanted to extend the functionality of this filter now with AutoGain functionality, even though that wouldn't fit into the logic of parameter smoothing, because I just decided that I want to use this filter for more things in the future. Okay, so now it said, thank you for providing additional code, and it explains what all of these methods are doing. Now I finally tell ChatGPT what's actually on my mind. I say, unfortunately, I have a little problem with this code. When I use this low-pass filter to remove high frequencies from a signal, it becomes quiet because the filter doesn't gain compensate. I think I have to change something about the setX method to make it work. It gave me some code in response to that, and what it changed was, typically I just had B1 equals X, and now it made B1 equals X times 1 minus A0 for the gain adjustment. And then it wrote very long text about how that gain compensates. It's kind of funny, you can read every single sentence here and it just has completely the same overall information, but just with different words. Really stop the video and check, it's kind of funny. Okay, so your changes work. Can you explain mathematically why this change worked? I asked it that because I wanted to know why the things even work, because I want to learn something from my experiences in coding. I don't just want to have solutions, I want to least know why the solutions work, at least if they are not going over my head. So let's explore the mathematical explanation behind the change. Nice way to phrase it. Okay, let's see. In a low-pass filter, the frequency response typically rolls off or attenuates higher frequencies while allowing lower frequencies to pass through relatively unaffected. The amount of attenuation depends on the filter's design and the cutoff frequency. In the original code you provided, the low-pass filter's transfer function can be expressed as transfer function boom. So this is the transfer function term, and for a long time I didn't understand what a transfer function is, but this is actually extremely useful because you can use the transfer function in a plugin, for example, to draw the filter response to the screen without having to calculate an FFT of an impulse that runs through the filter, which is a very costly operation. So with a transfer function you can speed that up. That just by the way, where z to the power of -1 represents the z-transform delay operator. The coefficients a0 and b1 determine the shape of the frequency response. So this is already where it's getting really complicated in my opinion. Like, I know a0 and b1 because these are the variables I work with, but then suddenly there is the z-transform, and I know that this has something to do with delays actually. So this is like looking into the past or something. I always have to wrap my head around that from the beginning whenever I read something about it. It just doesn't come easy. Anyway, when you apply this filter to a signal, the output signal y is given by... Yeah, okay, that explains the ProcessSample function, I think. One other thing that kind of annoys me about this whole thing is that you can't really know if everything that you read is actually factually correct, and that kind of annoys me and sometimes keeps me from actually attempting to ask ChatGPT about mathematical explanations, because I might learn from these things accidentally and then learn something wrong, while a real human being would have taught me the correct thing, and I might go out into the world and then tell other people that this is the thing that happens and I'm just wrong and I teach people the wrong things. I don't want that, and that's kind of awkward. That's why I usually don't use ChatGPT for these kind of things, but we are using it right now. We are making a little exception here and just see what happens. And if any one of my viewers knows a lot about these kind of things and sees some mistakes, then please let us know in the comments. Okay. In this equation, xn represents the input sample at time n, and yn minus 1 represents the previous output sample. So yeah, present and past, I get that. Issue with the original code is that it does not account for the gain of the filter. As a result, filter output may be attenuated. Yeah, that was my point. To address this, we modify set x as follows. Yeah, I already got that, yeah. Oh wait. Here is something new, so that the transfer function h of z remains close to 1, thus preserving the overall signal level. I think this is the part that should be highlighted here. Let's go back to hz. So if whatever is here equals 1, then the gain is compensated, or what? That's interesting. So okay, let's say a0, let's say x is 0, in which case 1 minus 0 is 1, and then x is 0, 0 times anything is 0, so this plus this is 1, and then times whatever this is also 1. Okay, I have no idea. However, it was pretty cool to just check what would happen if I attempted to get an explanation from ChatGPT about this DSP Math, which looks pretty simple, but really isn't. And I hope that none of the stuff ChatGPT said in this video is total bullshit, because otherwise this video will maybe get the wrong idea in some people's head. So everyone, please try to not take the things that you saw here too seriously. Might be all wrong, even though my low pass filter does work. Some of this might be wrong. At least the explanations, you can never really be sure. Okay, enough of this video, and see you next time.